The filoviruses are filamentous enveloped single-stranded RNA viruses that are negative sense strand. They look kind of elongated like this. They used to actually be classified with the rhabdoviruses, but now they're in their own group based on their genetics. It's not important that you remember what specific receptors they use to bind, but those specific receptors are usually pretty common, meaning these viruses can infect a lot of different types of cells. As a single-stranded negative sense strand RNA virus, they replicate within the cytoplasm. They don't go into the nucleus like some of the other ones we talked about. But I mentioned they can infect a lot of different kinds of cells: endothelial cells, monocytes, macrophages, dendritic cells, and others. Filoviruses are not super common. You generally won't see them in the US, but I'm talking about them because there was a very major outbreak a few years ago of one, and plus people always find these fascinating. So the filoviruses, when they get into monocytes and the monocytes go throughout the body, that leads to a cytokine storm. And when you have that cytokine storm, you can eventually get tissue necrosis in lots of different parts of the body. And remember, these also can infect endothelial cells. So you can get lysis of those endothelial cells, which can lead to vascular leakage. So maybe you already read this and kind of spoiled for you. One of the filoviruses is Ebola. The first symptoms of Ebola: headache, tiredness, fever, muscle soreness. What's that sound like? Flu-like symptoms. Okay. Then sudden high fever, vomiting blood, passive behavior, bruising, brain damage, bleeding from everywhere, loss of consciousness, seizures, massive internal bleeding, and death. So it starts with flu-like symptoms, and it leads to you bleeding to death. Without treatment, even with treatment, without treatment for sure, 90% mortality. With treatment, that's gotten better, still not great. Ebola is not the only filovirus. One of the other viruses is the Marburg virus. And the Marburg virus was so named because it was first identified in laboratory workers in Germany and Yugoslavia in 1967. So it was named after the area in Germany where it was found. The Ebola virus was named after the Ebola River in what was Zaire. I believe it is now the Democratic Republic of Congo. There are 5 strains of the Ebola virus that we know of. 4 of them kill people. One of them will kill other primates. It's called Ebola Reston, Reston. Reston is a city in Virginia. That's where the virus was found in primates that had been shipped from Africa. There's a really cool book about it, nonfiction. It's called The Hot Zone. National Geographic also did a Hot Zone like mini series, which was pretty cool. So I like to watch those types of things. I thought it was very interesting. Both of these viruses can kill susceptible populations really, really quickly. But again, that's something to think about, like when we talked about COVID and the idea that COVID has become far less virulent, meaning it doesn't cause really, really severe disease. The mortality rate is relatively low, 1%, but it spreads like gangbusters. Everybody, around the world, billions of people have gotten COVID. Maybe billions haven't been clinically diagnosed, but I would guarantee that billions have gotten the infection. Something like Ebola that can kill like 90% of people and causes symptoms like bleeding out of your eyeballs is one of those that maybe, I don't know, what do you think, may not be the best strategy evolutionarily for a viral infection. In some areas where the virus is endemic, so again, we're talking mostly like sub-Saharan Africa, It's estimated that more than 10% of the population actually has antibodies to the infection, indicating that they might have been exposed, but had what we call a subclinical infection. So the virus load was enough to stimulate an immune response, but was not enough to cause disease. It's almost like a natural vaccination. And the normal host for Ebola virus and Marburg is thought to be fruit bats. There are a lot of really interesting hypotheses about why bats carry so many infections and don't die of them. So it's thought that bats were the host of COVID, bats were the host of Ebola, bats are the host of Marburg. So if you're ever interested in reading about things like that, about disease ecology, really cool work in those fields. So Ebola in Marburg can be diagnosed by symptoms, but also by ELISA or reverse transcription PCR. So there are these portable DNA sequencers and RNA sequencers by a company called Nanopore. They plug into the computer and can do real-time sequencing. Those were really, really useful during the most recent Ebola outbreak, which was the largest outbreak in recorded history. Extreme care must be taken when working with filoviruses. You would never, ever, ever culture this in the lab, ever, ever, ever. You only would ever work with this if you worked in a biosafety level 4 lab. Watch like the first 10 minutes of the movie Outbreak and you'll see exactly what all these labs look like. Watch the rest of the movie Outbreak and see what a fictionalized Ebola outbreak looks like. So treatments are available using serum from people who've recovered from the infection, from artificial antibodies that have been created, interferon and ribavirin, which is a viral replication inhibitor. And there are companies that are working on developing vaccines right now. So this was the more recent Ebola outbreak. I don't remember exactly how many people were infected, but this is how many people died. So 11,000 total, including one in the US. That was drama, that the patient was in Dallas and had Ebola. Again, highly recommend reading about it. Very, very interesting, but not something we spend a ton of time on because it's not something that you are likely to see working in a clinical setting unless you are working in these parts of Africa.